All right. Okay, so we did what we've done so far with probability. We've done probability of simple events. We've done probability or finding outcomes. Okay, permutations is different. Okay. First of all, the main things you need to keep in mind with a permutation. Okay, a permutation order is important. Okay, and I tell you that because there's another lesson where we have order that is not important. Okay? So permutation order is important. Now, let's say I took 4 people. Okay? Actually, let's say 5 people. Okay? Let's say I have 5 people, and let's say I have Sage, I have Lance, I have Kylie, I have Elizabeth, and I have Jimmy. Okay. If I had those 5 people, okay, and I wanted to see how many different ways I could put them in order. Okay? In other words, like I could have, that's one order right there, right? And then let's say I switch Lance and Kylie. That's another complete different order, right? How many different ways could I arrange that group of 5, do you think? What do you think? 25, okay, good guess. Okay, what are some other guesses that we have? 50, okay, good guess. 3,125, okay, good guess. Okay. No, it's a good guess, yeah. A lot. Oh, that's a really good answer. Okay. Okay, so you were kind of close on the right track. First of all, how many choices do I have here? There's 5. So that first, if I was putting these into order like in seats, okay, that first seat can have any of the 5 people, right? Now, regardless of who I chose for that first one, how many would be left for the second seat? 4. Okay, so this second one would be 4. What would the third one be? 3. And then 2, and then 1. Okay? You see how I have these numbers and I multiply all the way down. So 5 times 4 is 20, times 3 is 60, times 2 is 120. There's 120 different ways that I could arrange that group of 5. Does that make sense?
No.
Okay. Because I'm going all the way down to 1. Okay? In other words, I'm including everybody in that group. Okay? That's what we call a factorial. You do. Okay? And a factorial, okay, it has an exclamation point. Okay? See how this is an exclamation point? Okay? It doesn't mean 5 because it's an exclamation point. All right. It doesn't mean 5. Okay. The reason I did that is because there's an exclamation point. What that exclamation? If you look on your calculator, if you're using one of mine, okay, press the 5. Everybody press the 5, and then press the green second button. Okay, then press the 3.
Wait, what button?
Okay, everybody stop talking. 5, second, the green button, and then press the 3. Okay, and you'll see 120. Now, some of you that are not using my calculator, look for this button, and it's usually a second button, which is kind of like shift. Okay, it'll probably show something like that. Okay, so that's a factorial. So, just to put it in perspective. Okay, there are 20 people in this class. Okay, if I took all of you out into the parking lot and I said, I want you to find how many ways you can arrange this group of 20. Okay. How many of you think you could do that? How many of you think you could do that if I gave you the entire day? Could you do it?
Oh, yeah.
You think you could? The entire day?
From 12 in the morning to
24
12 in the
So
morning.
I would give you a week to see if you could do it.
Yeah.
Think you could do it in a week?
A week, yeah. A week, yeah.
No.
Okay.
2.432902.
Yeah, that's not possible.
Here's
We can just start breaking.
what you're looking at. if I have 20 factorial, somebody press that button on your calculator. Tell me what you get.
2.43290228.
Okay, do you see that 18 at the end?
Yes.
Okay, what that means is 2.4 times 10 to the 18th power, which means, think back to when we did scientific notation, 2.4, and then we're going to move this 18 places. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So I think even if I gave you a year, I think even if I gave you a lifetime, there's no, I don't even know what number this is. This is like 240 Yamama million. I don't know what it is. Okay? That's a huge number, but there's no way you could.
Gajillion?
No, you couldn't, James. No, you couldn't.
Is that a real number? Gajillion?
I don't know.
You would die,
Right.
Dave.
Oh, you could. Okay, now, listen. That's what we call a factorial. So anytime you see a number, let's just say, let's put this into perspective with probability. If I said you had 9 baseball cards, how many ways could you arrange those on a shelf? What would you do to figure that out? 9 times what? Times 8 times 7. Because that first look, if you had 9 slots, Lance, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And you had 9 different slots, okay? And you can put any one of them first. How many choices do you have for that first one?
9.
You have 9. But it doesn't matter which one you chose. If you take one, you now have 8.
That makes sense.
Okay? You go all the way down. So somebody tell me, what is 9 factorial? 362,880. Okay, it doesn't seem like you could take just 9 baseball cards, but that's how many different combinations you would have. Now, if you put it into perspective, every single one is different. If I had, the first one is Mickey Mantle, then I could take those 8 and Mickey Mantle, or Babe Ruth, whoever. And if I can redo those, every time I just move one, that's a whole nother outcome. Does that make sense? Question. You press second and then 3. Do you see the exclamation point above the 3? And the reason it's in green is because that's a second function on your calculator.
Yeah, why do you press 3?
Okay, look, guys. Don't talk, please. Listen. Okay, do you see how this do you see how this is green and it says second? Okay. If you look above every key, okay, there's a function in green. Okay, so if you press that second button, that's what that's doing. It like changes the buttons that you have. It's like shift when you press it on a keyboard and it makes capitals. Okay, like that. All right, so that part's done. Do you understand that? Factorials. Okay. Now, what if I said, how many ways the 20 people in this classroom, let's say you had some kind of contest, okay? I have 20 people. How many different combinations could I have for the first 4? First, second, third, and fourth. Okay, well, first of all, when you see this, when we did this earlier this week, meant the probability of me getting a 3, right? Like if I was rolling a die, that would be the probability of me getting a 3, right? When you see it with 2 numbers like this, okay, this means a permutation, write this down, a permutation of 20 4 spots, okay? Now, this is actually pretty easy, okay? If all of you had a contest, okay, how many people can win first spot? 1, but how many of you could win first spot? Any of the 20, right? So this would be 20. Now, how many could win the second spot? 19. How many could win the third spot?
18.
And then? Now, somebody tell me why I stopped right here. Because it's 4 spots, okay? So this is 1, 2, 3, 4. Then I find this. What is 20 times 19 times? Somebody do that on the calculator real quick. There's not a button you can press for that, by the way.
It's 617,814.
I have no idea if that's true. I'm just going to trust you. Okay? So let's go back to those baseball cards. Okay? If I have baseball cards, I have 9 baseball cards. How many ways can I arrange the first 5? Okay? That's a permutation of 9. How many spots?
4.
5 spots. So I'm going to start, what do I start with? How many choices for that first one? 9. How many for the second one? 8, 7, 6, 5. Now, why do I stop at 5? Because there are 5 spots. So 1, 2, 3, 4, 5. Okay, what is 9? A combination or a permutation of 9 5 spots? 15,100 and what? Okay. Does that make sense? Yeah? It's not that difficult. What if I gave you something like this? Permutation of 101, 3. What does that mean I'm going to do? What does that mean?
3 spots and 101 chances.
What do I start with?
101.
Start with 101. What's next?
3.
What's last? And I stop there because I'm going how many spots?
3 spots.
3 spots, right? 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 Wakey wakey. Okay. All right. Do you understand that? How permutations work?
From a
Okay.
scale of 1 to 10, I understand it about a 6.
Well, that's a D minus, so that's good enough.
Oh, wow.
Well, a 6 out of 10 is a 60, so that's where that came from. So if he had said 7, it would have been a C. Oh, forget it, man.
That's just a